Awesome. All right. Let's get started. Then welcome, everyone. Welcome to my talk about the state of Amper. I hope you had a great lunch and that you spent your little nap time during the 2 previous talks. Now you got the fresh batch of coffee for this one. So yeah, before we get started, actually, I would like to know how many of you are here because of the keynote announcement about the Kotlin Toolchain? Oh, not that many. OK. How many of you knew about Amper before the keynote? All right, that's cool. Wow, that warms my heart. All right, great. And one last question, actually. How many of you actually used Amper in some project? Pet projects count, like tried it? OK, some little interest. OK, that's good. Well, my name is Joffrey, Bion. I've been working on Amper for about 3 years now, and I've been working at JetBrains for double that. And I'm super excited to be here, super excited to talk about this Amper initiative. So the people who paid attention during the keynote and know already about the Kotlin Toolchain thing, I will get to it, I promise. Just bear with me for 4 slides, and I will get there. But first, I'll talk about what Amper is, or rather was, and we'll get it from there. So what is Amper? Spoiler alert, it's not a Gradle plugin. It hasn't been for a long time. If some of you heard about Amper back in the time where it was a Gradle plugin and never heard about it ever again, I suggest you have a look at the Dima Sabinov's talk from last Kotlin Conf, where he explained the transition quite well. But this is about Amper, the actual build tool, like Maven or Gradle. So it's a build tool for Kotlin that focuses on UX and tooling. And I'll break that down for you. So let's start with what a build tool for Kotlin is, and more specifically, a build tool. When I say build tool, I mean the following. It's a tool that first gives some structure to your project, defines the project, the modules, and how they relate to each other. It provisions what you need to build your project, so dependencies, tool chains, and all this. Then it actually does the work. It compiles your file, runs the processors, annotation processors, KSP processors, code generation before compiling, all this to do the actual work. That's why it's called a build tool. And after that, usually you want to check that everything works. You run the unit tests, linters, report problems. That's how you integrate it into your CI, or maybe your reviews as well, pull requests. And the next natural step is to package this compiler output into something useful for users, and then share it with the world, being it a library that you want to publish to Maven, or maybe an application that you want to put on a CDN or something. So that's the main pipeline of what a build tool usually is. That's what it means to build your project. Right? But usually what we put behind the word build tool, it's actually a bit more than building. You want it to be the entry point to interact with your project. So you want to be able to run your application, maybe run with hot reload or live reload, depending on the tech that you're using. You want to debug, you want to profile your app. So and all of this with like caching and telemetry. So a build tool is a bit more than just build. I don't know why we stuck with this build term, but that's what I mean. A lot of things are going on here, and we want to handle as much as possible. So that's a build tool, but I said a build tool for Kotlin. And usually when I say this, people say, well, Kotlin is a lot of things. Kotlin is multi-platform, so there's lots of stuff there. So what do you mean when you say build tool for Kotlin? So let's see. What can Amper actually build? And let's start with the core of what Kotlin was or is. It's the Kotlin JVM world. So of course, Amper can build JVM libraries. It can build server applications like Ktor or Spring. It can build desktop applications as well, in console or even with a UI or Swing for the real. But of course, Kotlin is not only JVM, right? Kotlin is multi-platform. So when I say that Amper builds libraries, it builds also multi-platform libraries. When I say Amper builds desktop applications, it can build also native Linux, macOS, Windows applications. And we can't talk about Kotlin multi-platform without talking about mobile as well. So it can build Android applications, iOS applications, and it can, last but not least, also build web stuff with the Kotlin JS or Kotlin WASM technologies. Although I have to admit that this is still a little work in progress, but I didn't lie to you. Amper can build it, it just can't run or test it. Who needs that, right? So we'll get there eventually, I promise. So you can see you can do all of these individual things, or you can do a little bit of everything together by using technologies like Compose Multi-Platform, for instance. And all of this is also built into Amper. So yeah, back to our definition. I'll still have to leave out the second part for now, because we are now on the 5th slide, and I said I would address the Kotlin Toolchain thing on the 5th slide. So we have this build tool, which is a bit more than build, for Kotlin and for everything that Kotlin has to offer, as we've just seen. So we figured everyone that builds Kotlin projects actually needs something like this. And everyone should have something like this. And we figured with JetBrains, right? We build both of these things. We build Amper and we build Kotlin, the programming language and the compiler and toolchains and stuff. So why not make it part of the default offering so that when you are downloading Kotlin and you want to work with a project, you get everything you need to work with a Kotlin project. And that's why the Kotlin Toolchain was born. It's a single unified entry point into Kotlin, so you just need this, and you can do everything you need with your project. And that means that with just one command to install it, you can pick, there's two here, but you can pick one of them, the package manager of your choice, or just the simple script execution. You get that installed on your machine, and then you get the CLI with all the commands that you used to know from Amper, and you can just use that in your project as Kotlin now. So Kotlin init, Kotlin build, check, test, run, package, you name it. You get everything there. And we'll introduce more things, because this is still all part of the building pipeline that I showed you earlier. But we intend to add more things like maybe LSP, skills, things that are around the build, but not quite just building. And this is already in alpha. So Amper was experimental. Now we make it part of this Kotlin toolchain that will be a bit more than just Amper. And this is alpha. So it means JetBrains is committed to support it. You can use it. You can try it. We are eager to get your feedback about this, because we think it's really cool and we really want to know how to make it even cooler. So, like my people back in France like to say, Amper is dead, long live the Kotlin toolchain. So actually, thank you. Actually, this talk should have been called the State of the Kotlin Toolchain. So, hello everyone, welcome to my talk about the Kotlin Toolchain. Deja vu, right? So what is it? It's a unified entry point into Kotlin that provides everything you need to build your Kotlin project. And here it is again, with a focus on user experience and tooling. So now I can finally address this last bit that I've been pushing for a while. What does it mean to focus on user experience and tooling for us? It doesn't mean dropping everything else, right? When I say we focus on UX experience, we care about performance, we care about correctness, very much. But it's more like a philosophy that informs how we think about new features, how we design them, how we implement them. So let me try to break it down. The goal is for people to have fun and be more efficient. And everybody says this, but it's actually true. And we are the first users of it. We've been using Amper for a while. Now we are using the Kotlin Toolchain already to build the Kotlin Toolchain itself. And we're having fun with it. And we care when we are not having fun to fix the problems and make it so we have fun. So it's a bit selfish. So what do I mean by this? Let's get a bit more specific. We have the first thing I want to talk about is anticipating the needs of the users of this thing. And this is done via reasonable defaults and built-in features. And reasonable defaults give you the fact that you have fewer required choices. You have less obstacles to get things done. We want, if there is an obvious choice between two things that most users will pick, then we'll just provide that if it's harmless. And built-in features mean fewer plugins, right? You don't need to download 5 plugins to get your library published to Maven Central, because it's something so common that we really want to get it built in. So let's see a few examples. Here are some examples of the default that we provide with the Kotlin toolchain. For instance, Maven repositories. A lot of people get started on a project, they really don't care about the repositories themselves, they just want to add dependencies. And Maven Central often provides everything you need. Google sometimes for some Android-specific stuff. So we figure these are good defaults. You can, of course, customize it, but it's just one less choice to make, one less explicit thing to add in your config. And we have also the default main class. If you usually, when you want to run a JVM application, you have to provide this fully qualified name of a main class. And when you get started, if you just follow this main KT convention and you put a main function in it, the Kotlin toolchain will find it, it will run it. You don't have to specify anything explicitly in your config. That's also one thing that removes some of the friction. Another point is default platforms. So if you've not used the Kotlin toolchain before, when you define a module file, you have this product type that you choose, the thing on the left here, iOS app. So it defines what you want to build. And then you have the list of platforms. Because Kotlin is multi-platform, you might want to build different things. But if you choose iOS app, most likely what you mean is you want to run this thing on iOS simulators and on the real device. So we'll provide these platforms for you. If you want to change that, you can, but it's like usually the default cuts it here. And last but not least, default versions. That's kind of the obvious. Providing a default JDK, Kotlin version, Compose version, that's also what we want to do. So that's about defaults, but you have built-in features as well that kind of go together with default. And this is kind of a fun brag to be able to say, well, this module file is a one-liner, and that's cool, we can build an application like this, but it's not real, right? Nobody writes this, nobody uses this. So let's make it a little bit more real. By adding a few more lines. So let's say you're building this Spring Boot application, you add a dependency on Webflux here, which you get from the generated catalog, and that's what you write, but what you actually get is more something like this. So it's really small because there's lots of stuff there. But when you work with a Spring project, you want to enable a couple compiler plugins, like no args, all open compiler plugin. You have some annotation processing going on. You have some JVM compiler arguments there. So you don't want to think about all these things. You just want it to work. And when you enable Spring, that's what we do for you, because most people that work with Spring will need these things. So that's one example, but it's actually true for all of these built-in technologies that we have inside the Kotlin toolchain. By the way, if I say Amper anytime here, I've been working with it for 3 years, so it's hard for me to just say the Kotlin toolchain. So if it slips, just forget it. So that's about the anticipating your needs. But when that's like the goal is for you not to have to write configuration, but obviously you have to write configuration at some point. And when you do, we want to prevent problems with early and actionable and detailed diagnostics. So some examples of this is, let's say you have module file here, it's an application, and you have this setting JVM release. Are you all familiar with what the release setting means? Do you know what JVM release is? It's basically combine effects between the source, target, and API level. So source language, the Java sources will have some language level, the bytecode output will be at some level, and the APIs that you can use, like HTTP client or this kind of things that are in the JDK, will also be limited depending on this value. So essentially, this encapsulates, like, this is the minimum JVM my thing can run on. And when you say this, and then you depend on a module that defines that its minimum JVM is 21, there's a problem here, right? If you're trying to run this application with that module that's compiled for 21 on a JVM 17, it will break. And the Kotlin toolchain knows about all your modules. It's actually declarative, so very quickly we can pick up on these kind of inconsistencies in the model. So we'll see, well, wait a second, this is wrong. So one of these three things has to change, right? So we'll highlight the different points that come together into a problem. You have this module, my app, it uses this JVM release 17, but it depends on this other module that has a higher JVM release. That doesn't work. And the same kind of thing applies to other properties like this that are kind of transitive. So, for instance, if you have this SDK library with some publishing configured, you want to publish it to Maven, you want some people to use it, and you depend on a module that has no publishing defined, there's a problem as well. If someone depends on your Maven library, it cannot pull this transitive dependency, it will break at runtime. So you also get this error of inconsistency in the configuration. So that's what it means. We detect these things early because they are easy to find, right? It's just even in the configuration, you can already see that there's a problem here. And the last one that I want to show to you is one of my favorites. It's sorry, it's small on the slide, but it's so cool I could not show it without the screenshot. So what happens is you declare a dependency here on Kotlin X Coroutines core 1.8.0, and some of the other dependency in your graph brings, for some reason, a higher version of coroutines. Well, here I made it a bit extreme by 1.8.0, but you get the gist. So some dependency brings 1.10.2, and you want to know about this. It's always, like, it's not a problem in general in your dependency graph to have conflicts in versions. It happens all the time, and it's fine, and the dependency resolution will fix that. But when you declare something here, and it's changed by the resolution, then something is wrong. You're lying in this config file, because it's actually explicitly listed here that you wanted 1.8. So probably you want to say that you actually want 1.10.2, or you want to fix some of the other dependencies so this conflict doesn't happen. And this is really fun. You can see the whole graph of things, of dependencies that brought this new version for you. And if you're not looking at your different config files here and there, because we don't really need to look at them sometimes, you have this sync tool window in the IDE that kind of aggregates all the errors and issues that you have. But you might ask, well, what if I'm not in an IDE, right? And you're right, and you'll be happy to know that actually most of these diagnostics, the vast majority of them, are on the CLI already. So it's not inspections in the IDE only. If you run the CLI, you'll see these errors as well, or warnings as well. So some AI agents might be happy with this and can interact with it and act upon it if we make them accessible enough or actionable enough. So yeah, we prevent issues early as much as possible. And the last point is to try to be invisible. And deep IDE integration is the way we found to do this, which is basically we don't want you to have to go out of your Kotlin code. So let's say you have this, sorry again, it's a bit small in this slide, but I really want to show it, to show the big picture here. Let's assume you have this Kotlin scope declaration or usage. It's an unresolved reference. You forgot the Kotlin library. You have this quick fix to add the Kotlin library, but what you see is just you apply the quick fix, and then you get green code. Or rather yellow, but that's just my color theme. It's code that works. And what actually happens behind the scenes is that, well, you had a module file without the dependency, now you have a module file with the dependency, and that's why you have green code, right? But you don't see this in general, and that's the idea. You want to stay in the Kotlin code to not get out of your flow as you're writing things. So you can see that in other examples, like if you're configuring this Ktor application, you want to install some plugins in your Ktor app, you just type install, you have some autocomplete, that's nice. You want to install Kug, you get there, you don't see the module file changes, you just see that your code becomes green. It's also the case if you want to use some new language feature that requires some experimental compiler flag. We add the compiler flag for you behind the scenes, and you get the green code again. And last example is opt-ins. You see a lot of those. You have a lot of options to fix such opt-ins, right? You have this global scope declaration. It requires an opt-in because it's a bit delicate to use. And you can opt in at the statement level. You can opt in at the function level a little bit above. You can opt in at the file level. All of this is just annotations. So if you do it, you see it in your Kotlin file. And there's no reason for the fourth option, which is opting it at the module level, to be different, right? But this one needs a compiler argument in the module files, and you don't want to have to switch to that to go make your changes. So we'll just do it for you, and then you'll see that it works. So that's it. Yeah, that's what I mean when I say we focus on UX and tooling. We try to feel in which places we need to be present and in which places we need to be invisible. So enough about the philosophy and all the high-level hand-waving things. Let's get into real features. So what's new since last year? Maybe last year is a bit too much. I don't have time. It's already, we have 26 minutes left, so I can't cover everything that happened. Maybe from the beginning of this year, but it's already too much as well. Let's see quickly what we have. We had customization of the JDK provisioning, because we used to be only able to provide the JDK 21 hard-coded. Now you can choose, you can make sure that everyone that uses your project will get the correct JDK, and it's rather consistent. We have third-party compiler plugins, so now you can use Coin, or the new version of Coin, for instance, or Metro, or Test Balloon. This is also built in. I don't have time to detail this, but if you go to the docs, you'll find that it's actually pretty simple. Another cool thing that was there is dependency insights. So I'm listing here all the things I can't actually talk about because I don't have time, but I can't help but saying a little bit about them because I'm so excited about this. So this Kotlin show dependencies is actually quite useful. It shows you the whole dependency graph of your project. And when you want to investigate a little bit what happened with dependency resolution conflicts, you can just filter that graph with the coordinates of one dependency, and it will give you all the paths to that dependency so you can know who won and why the conflict resolution. So it's pretty interesting. One initiative that was very nice is the dependency graph caching. And because of that, we could enable the autosync. Why? Because when we think about dependency resolution and why it's slow, we usually think about the downloads of the files, right? You say, well, we have to download a bunch of POM files, jar files, put them on the disk. But actually, once it's already on disk, it's still a bit slow. And because you still have to resolve the whole dependency graph, you still have to look at all these POM files to find the transitive dependencies, to resolve the conflicts, to build the actual graph in memory. And that takes time. And actually, we don't have to spend that time because a lot of the times you don't modify your dependencies, so we can just serialize this graph as it is and deserialize it when it's ready. And that's what we do. And that's why when you change module files now, it's just a couple of keystrokes, save, and instantly you get the new model synced with your IDE. So your new module is there. You don't need to think about it and to spend time. And of course, this only works if you don't change any of the dependencies. That's a bit unfortunate. So we're thinking about improving things. Actually, here, we haven't released anything in this respect, but we're looking into options. And the idea would be to have some incrementality here. So even if you just bump a version or add a dependency, we can still pretty much reuse a lot of the work to resolve the graph and then just do the little bit extra that's needed. So we'll get there eventually. Stay tuned, we'll have something for you. Other things I can't talk about is the ton of IDE improvements that we made. Quick fixes, main class assistance, you name it, there's a bunch of things there. What I can talk about, though, is the Maven Central publication preview and the plugins preview. So I'll spend a little bit of time on this. Let's start with Maven Central publication. And the reason why it took a little bit of time to get there, so as I said before, we really want to have built-in features for things everybody needs, right? So Maven Central publication is one of them. When you have a library that you want to get there, it's a lot of little moving parts in Maven Central, and we want to make that easy. So the reason it took some time to get it is that because Maven Central has a bunch of requirements for you. It requires you to sign your artifacts. It requires you to provide a bunch of data in your pom.xml that are mandatory, licenses, SCM URL, developers, these kind of things. You need a sources jar, you need the Java.doc jar. So there's all these requirements, and we need all the corresponding features in the Kotlin toolchain to be able to cover this, to enable you to provide this information. And last but not least, Maven Central is a bit special now. It requires you to publish through a different API than the regular Maven libraries do. So when you publish to a normal Maven repository, there's some way to interact with it. With Maven Central now, there's a new way where you publish a big zip bundle through an API that's a bit different. So it needed also some special attention here. But we got there. So how does it look? You can have this library module with a few coordinates here, publishing enabled, that's fun. If you want to publish that to Maven Central, you just have to add one more line. Well, of course, you need more than that. It doesn't work, because Maven requires a bunch of things. That's the whole point. But you know about them, and you can fix them. And actually, if you really want, so you need to fix the signing, you need to fix the publishing of the sources, and you need to provide a bunch of things in the POM file. You don't have to read all of the details here, but how you fix it is just you provide this in the POM file, in the module file, sorry. So you get the sign artifacts, you get published sources, and some information in the POM. So it might seem like a lot, but it's actually quite condensed here. And we're quite happy with the result here. So with one command, then, you can just do Kotlin publish Maven Central, and then the library is there. There's some subtlety here. There's a couple modes where you can actually stop in the middle to actually check your artifacts before releasing it. So you can choose between the two modes. But it's a single command still. And this is just a preview. There's some polishing that needs to be done, but I would be happy if you try it and let me know what's wrong with it, if you find some difficulties, especially around the credentials passing. We'll improve things about how we pass credentials there. For now, it's a few environment variables, but it's not for everyone. So that's for Maven Central. We also have plugins to talk about. And that's a big feature that was demanded by a lot of people. Because, well, we can't, as much as we want to provide everything built in, there are things that you can't provide built in. And plugins are an important part of that. So what can they do? Why do you need plugins? The idea of a plugin is to plug in the system, right? So you need to get information from the build and then contribute back to the build. And the kind of information you can get from the build is the sources, the resources, the compilation output, maybe you want the jar. You can get also like random files on your disk or even Maven dependencies. You get some coordinates. The Kotlin toolchain resolve these dependencies for you and then gives you the jar. So as a plugin author, you get the jars for each of the dependencies. So that's the kind of input you can get. And then you can provide back to the build some generated sources or resources, classes, even C-interrupt definitions now. We have C-interrupt as well. And that's how you contribute back to the build. That's when you want to insert things inside so you are part of the compilation. But there are some things that you want at a higher level. And for instance, you might want to add custom checks. So if your plugin is about writing a linter or wrapping a linter like ktLint or detect, you can provide extra checks. And this Kotlin check command runs all the checks in your project, including tests that are part of it, but also all the custom checks of the plugins. So this could also be binary compatibility validation, for instance, or linters in general. That's a good use case for this. And checks are one thing, but sometimes you just want any custom entry point for your users as a plugin author, for your users to get something done. So for instance, if you write a plugin to generate a changelog, it reads issues, generates a changelog, that's how you would do it. So you expose a custom command that's effectively some sort of public task, and then the users can just do Kotlin do and that command and run it. So the idea here is that the little units of work inside your plugin, what we call the tasks, are not necessarily public, right? It's not necessarily entry points that you want to expose to your users. What you want is be intentional about this. So you want to add these custom commands on purpose and choose which of the tasks you expose. So we'll see a little bit how it looks like. So what does a plugin look like, actually? A plugin is just a module like any other module. You can have, for instance, your app a utils module, and let's say we add a build config plugin to the project. So you have this extra module. The layout looks a bit like this. We have your module files. What makes it a bit special is you have this extra file called plugin.yaml. And what's in the module file? It's just a simple product type, JVM amper plugin. Yeah, it's in alpha. We know there's a bunch of things that may change. This is definitely one of the things that will change because the name is a bit outdated now, but bear with me for a bit more. So this product type is to create your plugin module. And as a module of your project, actually this plugin can depend on other modules of your project. And that's, it sounds simple like this, but actually it means a lot. It means there is no meta build outside of your build. We don't prepare the plugins, we don't build the plugins before building your project. We build all we need as part of the same task graph. And that means you can reuse the same module for both your project and your plugins if it doesn't create a conflict or an actual cycle in the tasks. And it also means you can technically apply a plugin to itself if it doesn't involve like changing the compilation, for instance. So if your plugin is about generating some extra documentation file, why wouldn't you be able to use it in your own plugin? So you can apply a plugin to itself. That's a fun consequence of it. So to use your plugin in your project, you have to add it in the plugin section on your project YAML file. This is how you register your plugin to the build, because at first it was just a module in your build. Maybe you just want to publish this plugin, you don't want to use it in your build. So here is the way you use it inside your project. And then in each of the modules, you can decide to enable that plugin and get all its tasks and all its work that it proposes. So the checks and the commands and everything. So let's have a look at this plugin YAML file, because that's basically the core of what a plugin is and what makes it different from other modules. So what's in this build config plugin YAML? Essentially tasks. So you will provide these units of work, and you declare them in this declarative manner in plugin YAML by saying, okay, I have this task named generate config object. The implementation is this function in Kotlin. So you will write the implementation of the task in Kotlin. It's called the task action. And it's just a fully qualified name of a function here. So this function is defined in your Kotlin code. It has some parameters. The parameters you can provide and wire in the build directly from the YAML. So it takes two parameters here, properties file and config object output dir. So the role of this task is to read a properties file and to generate a Kotlin object with the properties in it so you can use it from Kotlin. I won't show the implementation of the task. It's pretty trivial. It's just about generating the Kotlin code that corresponds to properties, but we need to save a little bit of time. So this is actually how you expose the task to the build, or at least how you declare the task as part of your plugin. And then, to actually say what your plugin contributes to the build, you say, well, by the way, this task, what it generates is sources that need to be taken into account in your compilation. So you say, I'm generating sources. Here is the language. Here is the directory that contains the generated sources. And you don't have to wire any compilation tasks or wire these dependencies together. You will just say that this is what I contribute. So when you read the plugin YAML file, the consequence of this and the reason why it's no longer inside the tasks list at the top, because it used to be there, is because when you look at it, if you just hide the tasks block, all you see is the things that will be contributed to your modules build. And for instance here, it's the generated sources, but if you take the example of detect, for instance, it's a bit more than that. So detect is, for those who don't know, it's a linter. It will analyze your project and provide some errors or some messages about what happens. And it usually comes with two tasks. So one of them will check the errors in your project, and the other one is actually about generating a baseline of the current errors, so you can only report the diff between what you already had and the new errors. So you provide two tasks here, one to analyze, one to generate the new baseline. And the way you want them to interact with your build is through two different things. One is the checks. So you want to provide the analyze task as part of the checks. If you do Kotlin check, then you will get this analyze task running. And you want a custom command to be able to say, well, as a user, I want to update my baseline now, so please do this. So that's how it translates to the CLI, right? Kotlin check will run the check here, and Kotlin do update detect baseline will just generate this new baseline file. So here again, you see the checks and commands. If you forget about the tasks, you see how the plugin contributes to the rest of the build. Just like before, we could see this generated sources. Oh, that's a lot to go back. I should have thought about that before. So here you see generated sources, and over there you see this checks and the commands. Lots of clicky. Here we are. So yeah, I don't have that much time to talk about all the little features that we had, and I prefer to present a little bit what's coming next. So let's see our future plans. One of the main thing that we want to work on is improve the KMP experience, because so far it has fallen behind a little bit, and we want to invest in it. So one thing that was crucially missing, actually, it's the KMP libraries publication. So that's the first thing we will be working on. But there is also Swift Package Manager integration and Swift export in general. So we want to be able, built into the Kotlin toolchain, to be able to add the SPM dependencies there and work with Swift more comfortably. So that's one of the big things we intend to work on. And another one in the KMP story is Compose for web, and the WASM story. So as I told you earlier, it's still work in progress. We can't run things, we can't test things, because we don't provision yet runtimes for the JavaScript stuff. But this is coming. Another thing that we want to work on is the compatibility between the IDE plugin and the CLI. We want it to be a bit smoother, because the IDE at the moment is actually deeply integrated because it depends on parts of the CLI itself. So the CLI is kind of an application that has lots of modules in it, and these modules can be reused directly in the IDE, and that's why you get such a nice integration. But we want to introduce some layer in between so that you can use the IDE plugin with different versions of the Kotlin toolchain, because sometimes you work on different projects, and sometimes these different projects have different versions. So you can't just choose the IDE with the proper version all the time. So we want to work on this to make it easier. Another thing is to make it a little bit smoother to install. So we already now have a global installation of the Kotlin toolchain, which we didn't have in Amper. Now we have it. It's via SDK man that you can install it, or you can install through a script, but it's a bit better if we can provide it through the regular package managers that you might be used to. So that's one of the things we want to work on. And last but not least, performance. We aim for Kotlin toolchain to be quite easy to work with, and one of the things that we really like is this auto-sync and the way that it's fast. And we want also that for the CLI as well, because agents need to talk to the CLI and run a bunch of commands, and we don't want to pay the price of a slow startup there. So the slow startup might be solved with a native image, for instance. That's one of the options we are exploring. So maybe make the Kotlin CLI much faster using GraalVM or something like this. Another aspect is incremental Kotlin compilation, because for the moment we are doing compilation avoidance. We know that if a module doesn't change, we don't have necessarily to recompile the dependent modules, this kind of things. But if it's slight changes in the code that don't change the ABI, then we can do even better. We can avoid compiling more stuff. So be more precise in what we compile here. And with the Build Tools API, we have a lot of things that we can do now. If you heard about the Build Tools API in the keynote, for instance, there's a general effort to consolidate these kind of features for all the Build Tools consumers, and we are one of the consumers of this Build Tools API, so we will actually use that. We already use the Build Tools API for JVM compilation, and it will soon provide also support for the other platforms, so we can expand the use of that. And last but not least is the incremental dependency resolution that I talked to you about earlier. So we want resolution to be fast because that's one of the slow bits. And it can be fast if it's incremental, if you just change a little bit of versions or some libraries. So that's it. A few takeaways here. The Kotlin Toolchain is your new entry point to Kotlin. It covers all you need. So please, you need to try it. This is, it has great IDE integration. It's in the alpha phase. We are going to support it. So yeah, just get started. Follow this link. You can install the Kotlin Toolchain and play with it. We are really eager to hear your feedback and make it even better. Thanks a lot, everybody. I hope you liked it. And don't forget to vote. Thank you. We still have a few minutes for questions, if there is any. We have 9 minutes left, so... Oh, thank you.
Hey, thank you so much for the talk. I was wondering, I've seen other languages going through a similar path in which there's a lot of build tools that appear, and then one standard emerges, for example, with Python, that they converge to pyproject.toml, right? So in the morning, I've been to a talk by the Gradle folks talking about how they want to go declarative. And now we are talking about another way of doing declarative builds for Kotlin toolchain. So have you thought of standardizing somehow so that, for example, it's going to be easier for the detect fellows or Kotlin that are having to keep maintaining different plugins for different things, or even for people to migrate from one build tool to another?
I see. That's a great question. We are trying to extract the bits from the different... So first of all, we want to support all of these build tools, right? We don't want to replace everything. It's always useful. Some build tools have some pros and cons and different ways to approach things, so we want to support all of them. And we're trying to extract the common stuff as much as possible. That's the build tools API, for instance. So there are things that we at JetBrains can control, which is the compiler, maybe commonization between native platforms. So this will go in the build tools API. But not everything can be, like not everything is in our control. So we are doing our best to minimize the repetition of the code everywhere. But there are things that are fundamentally different, and we cancel all of that. So if there are some things like, I don't know, KTLint, as you said, that have to implement different plugins for different things, there is usually a way to write these tools with reusable modules and then just a little layer of adaptation for the different build tools. And we actually never discussed with the team some ways to align how this layer of adaptation could be standardized. I don't know if that would be possible, but it's an interesting idea. I'll check with the team if we can think about something there. But we haven't, to answer your question, we haven't yet thought about this. Yeah.
Cool, thanks.
There's another question here. Oh.
Hey. Amper gets better and better every year. Thank you very much. Really appreciate it. I love it. Use it for personal projects. I would love to push it forward with my company, corporate usage. I think it would be pretty sick. My question is, are the artifacts produced by Amper reproducible or not?
They should be. Did you have any problems with this specifically? Do you know?
Not really.
Because
I was just...
the way we built, sorry to interrupt, the way we built the jar, we already took into account this, like the timestamp story, the different aspects of building a jar that could make it non-reproducible. Normally, it should be standard now. So if you face any issue with this, don't hesitate to let us know. We have this Slack channel. It's still named Amper, I think, in the Kotlin Slack. Maybe that will change. But if you face any problems like this, we'll be eager to hear about it, because that's something that we care about. And especially all the caching story, we want things to be fast. So if things change all the time, that doesn't work, right? And we want to have some reproducibility. That's also why we had this effort about the JDK provisioning, so we can pin the JDK to some version, for instance. And yeah, reproducible jars is also something that we care about. So normally it should be. That's the answer. If you find any problems, let us know.
Firstly, yeah, thank you. And Hadi's promise from 2 years ago finally coming true, it looks like. 2 questions, if you don't mind. One, in the end, can I just fall back to the command line? Can I create a plugin that basically just says, well, I need to invoke this bit of bash?
Sorry, can you come again?
In the end, if I want to build a plugin, can I just invoke bash and say, run this, and it will output stuff into here?
So the way it's written right now is that you have to provide a Kotlin function.
Right.
But this Kotlin function can call anything. You can start a process if you want to. There's no direct bash call from the YAML declaration to this, so you have to go through Kotlin. At the moment, there's no cost to that because this Kotlin invocation is directly in the same process as the Amper process.
Right.
This will probably change, especially if we go GraalVM for the Amper process. I said Kotlin Toolchain, the Kotlin CLI process actually, because the toolchain is more like not an application, but the CLI process runs the plugins directly, so you don't get this extra cost. So you can just start this process yourself. We will most likely make it easy to implement plugins by providing some nice libraries. There is some APIs that we're thinking of. In terms of the Kotlin code can like feed back into the Kotlin CLI saying, well, by the way, I have this report, this diagnostic that I want to report, this kind of thing, so to send back information. So for this, we need some tighter integration. But for other things like starting processes, we can just provide some helper libraries that you can choose to use and make it a bit simpler to invoke a bash script if you need to. But why do you want to write bash?
Because one more. Amper used to be a build tool for Kotlin and Java.
Yes.
So now the Kotlin Toolchain is a build tool for Java.
It's one of the little nitty-gritty details here. We still do support Java, actually. It's just not the main concern of it, so I don't mention it as part of the definition because, especially at KotlinConf, but it's still there. We even have incremental compilation for Java already, but we don't have it for Kotlin. That's funny, but it's it's there. I don't think we will get rid of that. There's no point in that. It will be supported. It doesn't cost a lot to support it. But I don't want to commit too hard because it's easy to say things on stage and then I'll get beaten back home and saying, why did you say that? But yeah, there's no reason for it to disappear. So we do support Java. It's just like pure Java projects, for instance, are less of a concern. So for instance, by default, you'll always get the Kotlin standard library on your class path. And if you're building a pure Java project, that might seem a bit weird. And this is not something that we have in our priorities to make it different. But Java is supported.
So you have a really, really nice language, Kotlin. And it's called Kotlin Toolchain now, not Amper. But you're still using a markup language like YAML, and you can make really nice DSLs with Kotlin. So why?
I expected this question.
Sorry.
And I should have prepared more. But the thing is, we thought a lot about this thing. We thought a lot about how to improve this configuration language. We definitely wanted something declarative because it's really, really important for us that the import in the IDE or even the tooling support is fast and simple to write. And if you have imperative Kotlin code to declare your stuff, it's always a bit tricky, right? And one of the aspects also of it is that you would have to run third-party code to even know what your project is about. And that's the nasty little pop-up window that you get in the IntelliJ that will tell you, well, do you trust this project? Yes, no? Do you want to trust all the projects in the folder? We don't want to have that because it's not necessary. You can import the project without any risk if it's just YAML. YAML will not run. And so that's part of it. So that's why Kotlin doesn't quite fit the bill here. We could have nicer DSLs there, but if we invent a new language, that's also a lot of toil for other tools to integrate with it. If you write YAML, there are YAML parsers out there. If someone writes a Dependabot support for the Kotlin toolchain, they can just read the YAML file, right? If you start to create a new language, then everybody that needs to integrate with it will have to understand this new language. And there are some configuration languages out there that may or may not be better than YAML. And some of it is part of opinion-based ideas, I would say. but most of the time when I hear people's grievances with YAML, they are mostly outdated in our context. And but what I mean by that is that we own the parser, so there's no such thing as the Norway problem. There's no such thing as these like type problems, because our parser is type safe. It knows exactly the model of the Kotlin Toolchain project model. We know exactly the different pieces, so we can fail in very nice ways. If you use it, you will realize, well, that everything is type safe. Just like Kotlin, you will get the same warnings or errors there. And so the only real grievance that's still valid for YAML, I would say, is the white space sensitivity. And it is a big one, but I think it's mostly perception. So as we've seen a lot of other tools are using YAML there. I don't think there is a chance that we'll switch to something else now, because we've looked at it, and the more we think of it, the more we feel comfortable with keeping YAML. As bad as it can be in some respects, it's actually pretty good in general. It kind of pains me to say it, because I also don't like YAML that much. But honestly, having worked with it for 3 years, it really is almost never a problem. Maybe sometimes you press enter and you don't know where your cursor should be, but that's pretty much that. And that's pretty much it. Yeah. So not Kotlin, yes, not Kotlin. That's of course something we thought about at some point, but for the declaration of the project model, it actually doesn't really fit the bill. Sorry for the long answer.
It's fine, thanks.
I think we're almost out of time. We are out of time, sorry, 2 minutes over time. So I guess we have to stop here. Thanks a lot for coming, and thank you.